In the first section, we'll discuss naming alkenes. Alkenes differ from alkanes in that they have one or more double bonds. The IUPAC naming rules are similar to those for alkanes. Three differences are, first, the position or positions of the double bonds are identified in the name, like the positions of substituents. In this case, using the lowest numbered carbon in the double bond. Second, numbering begins from the side closest to the double bond, nearest an end carbon, not the side nearest the first substituent. And finally, the root name ends in ENE rather than ANE to signify that there is a double bond. If there are 2 or 3 double bonds, ENE is replaced by diene or triene. There are 2 different ways to indicate the number of the lowest numbered carbon in an alkene. One, butene, indicates that the double bond is on the first carbon. But you could also say but1ene, which indicates that as well. If there are 2 double bonds, the name could be either of these two. 1,3-butadiene, where the ENE is replaced by the diene. But you could also say but1,3-diene, where the ENE is replaced by diene. Either of these 2 systems could be used, so you should be familiar with both. All right, let's take a look at this example. We have butene here. So butene, there are 4 carbons. We know that because of this but prefix. And then ENE means that there's a double bond. And what I've shown here is 3 different representations of butene where the double bond is in 3 different locations. So in the first, it's between the first and second carbon, right here. In the second, it's between the second and third carbon in the middle. So this is carbon 2, carbon 3. And in the last, it's between the last 2 carbons. But if you notice, in the first and the last diagrams, we get the same compound, 1-butene or but1ene, because the numbering changes with the bond location. So I had to change, so here I have carbon 1 starting at the double bond, so 1, 2, 3, 4. Well, the same thing happens here where it gets reversed because we start our numbering closest to the double bond, so 1, 2, 3, 4. So in both cases, this is 1-butene. In the middle, it doesn't matter where we start our numbering, because if I start from here, I get 1, 2, and then my double bond. If I start over here, 1, 2, and then I get my double bond. Okay? So because this double bond starts at the second carbon, we would call this 2-butene, or we could also say but2ene. All right, let's jump right into our first example. We have a molecule shown, and after we follow our steps, we want to be able to name this molecule. So the steps are the same as in the previous unit on naming. It's just that now we're taking into account here that we have some multiple bonds. In this case, it's a double bond. So let's try to find our longest carbon chain. If I start here, I have 1, 2, 3. If I go this way, that's 4 carbons. If I go the other way, it's 4, 5, 6, 7. So that's our longest chain. It's right here. It's a 7-carbon chain. And a 7-carbon chain that includes a double bond would be heptene. All right, the next step is to number the carbons, and in order to do that, we have to locate the double bond and make sure we start our numbering on that end. So you can see the double bond here. So this right side is closest to it, so I'll start my numbering there. So it's 1, 2, 3, 4, 5, 6, 7. Okay. All right, you can see in the diagram the numbering that we did from the previous slide. And again, just to point out, the numbering begins from the end carbon closest to the double bond. Now, just like in previous sections, we need to identify and name the substituent. We can see the substituent right here coming off of this 5th carbon, and it's a 1 carbon group. So we would call that a methyl group. All right, the next step, determine the carbon for the double bond and the substituent. So I'm just going to circle in red. The double bond is right here between carbons 2 and 3. So it starts at carbon 2. And then the substituent is right here in green coming off of carbon 5. So carbons 2 and 5 are the important carbons there. Okay, so the last step, once we've identified those important carbons, is to name the molecule. So we'll start with the substituents. So we've got 5-methyl, and then it's heptene, but where is the double bond? The double bond is on carbon 2, so we'll say 2-heptene. So 5-methyl, 2-heptene. All right, so you can see down here in step 5, here's the name we wrote, 5-methyl, 2-heptene. And just as a reminder, if you want, you can place the double bond that the carbon is on before this ene. So we could have also said 5-methyl, hept-2-ene. It's up to you. They're both correct. So I'll often write the first one, but we'll show both options in our answer choices. All right, here's our second example. You can see the structure on the right-hand side of the screen. We need to first identify and name the main chain. So let me see if I can't find the longest chain of carbons. If I start here, then I have 1, 2. I could also start here and get 1, 2. 3, 4. If I go this way, I get 5. If I go this way, I get 6, 7. Okay, so that's what I'm going to do. So let me circle. Now let me make sure again. 1, 2, 3, 4, 5, 6. I'm counted. I miscounted. That's why I generally like to double check. So 1, 2, 3, 4, 5, 6. So a 6 carbon chain with a double bond right here would be hexene. Hexene. Keep in mind, when you're trying to identify the main chain, you have to make sure that you prioritize the double bond. That has to be in your main chain. So you can see highlighted the 6 carbon chain that we found in the previous slide and named here hexene. So now we locate the double bond, which we see right here, and then we number the carbons. And so remember, we need to make sure that we start on the end that's closest to the double bond. In this case, it doesn't matter because the double bond is right in the middle. So if I start here, then I would get 1, 2, 3. If I start here, then I would get 1, 2, 3. So just because it's easier to read from left to right, that's what I'm going to do. So 1, 2, 3, 4, 5, 6. So there's our carbon numbering to make sure we're including the double bond. All right, so again, indicated on the diagram is that same numbering that we showed on the previous slide. And remember, we could have begun on either side because we just make sure that we make sure that that double bond has the lowest number. We do have to make sure we start our numbering from the left in this case because we're not only preferencing the double bonds, we also have to preference our substituent groups. So In this case, we get to our first substituent first. So if we'd started here with our numbering and said 1, 2, 3, then this substituent group would have a 3. And so we get a lower substituent group number if we start on the left-hand side. Okay, so the double bond placement, we can start our numbering wherever we want, but we have to also take into account our substituent groups. So now let's identify and number those groups. So there are 2, one here and one here, and they're both methyl groups. All right, we have 2 methyl groups. Now that we've identified the 2 methyl groups, let's determine the carbon for the double bond. So the double bond carbon is carbon 3. Okay. And we have 2 carbons for the substituent groups, carbon 2 and carbon 4. Okay. All right, finally, let's name the molecule. So let's start with our substituent groups. So 2,4-dimethyl, and then 3-hexene. 2,4-dimethyl, 3-hexene. Remember, you could have also said 2,4-dimethyl hex 3-ene if you'd chosen. All right, just as a summary for this example, here's all the steps that we took, and just our final step here is writing the name of the molecule, 2,4-dimethyl 3-hexene. And the reason that we follow this stepwise approach is just to make sure that by the time we get to naming the molecule, it's very straightforward, just compiling the information that we already have. All right, here's example 3. You can see the diagram on the right, and our ultimate goal through these 5 steps is to write the name for this molecule. So we start by identifying and naming the main chain. So we just have a straight chain here. So we just have this long chain right here of 1, 2, 3, 4 carbons. Okay, so 4 carbons is bute. And because there's double bond, we'll say butene. All right, once we've identified and named the main chain as butene, we need to locate the double bond or bonds and number the carbons. So we can see 2 double bonds, one here and one here. And we want to number the carbons on the end closest to the double bond. Since there are 2 double bonds here and they're both on either end, and we don't have any substituent groups, we can actually start numbering from either end, but I'll start here with 1, 2, 3, 4, so that we're starting our double bond on carbon 1. All right, once we've numbered and located the double bonds, we have to look for any substituents and name them. You can see here there are no carbons branching off of the main chain. There's just the 4 carbons in the main chain. So there are no substituent groups. So we'll just say none there. After that, we determine the carbon for the double bonds and for the substituents. So in this case, we just have 2 carbons. And we got to pick the lowest number. So if this is my double bond, the first one is carbon 1. And my second double bond, it's between carbon 3 and 4, so carbon 3. So carbons 1 and 3 are the double bond carbons. And there are no substituent carbons, so we don't have to worry about those. Finally, we need to write the name of this molecule. So because there are no substituent groups, we can simply start with the carbons for the double bond. So 1, 3. So we would say butene, but because there are 2 double bonds, we say butadiene. butadiene. So this di here, the prefix for 2 to tell us that there are 2 double bonds. One on carbon 1 and one on carbon 3. 1,3-butadiene. Also, just as a reminder, we could say but-1,3-diene, where we put the numbers of those double bond carbons in the middle of the name. Or we can do, as I showed on the previous slide, 1,3-butadiene. Because there are 2 double bonds, the ene has been replaced by a diene in the name, butadiene.